Hi guys, and welcome to CodeChef Starters 39. I took part in it in Division 1, which is unrated, and I already solved all problems and I figured why not share it. This time we have 6 unrated problem or non-scorable problems for Div 1, so only 4 scorable. So this contest was very easy for Div 1 participants, but I still think that some lower rated participants may benefit from learning something from it. You can see that even Div 1 problems are getting a lot of solves, so they are not particularly difficult. I only got rank 12, but that's because majority of people start with scorable problems and I start with non-scorable. So before I even got to this, I had to go through all of this, and this time there are 6 of them. So yeah, that kind of didn't play in my favor, but it doesn't matter because it's unrated. So first problem, my first contest, there are some rules about how you get or not get rated in your first contest. So the thing is, there are n new users. Some of them don't submit anything, they don't get rated. Some of them try to submit something, but they couldn't solve anything, so they get low rating. Others can solve something, they solved something, so they will get a strictly higher rating. I wanted to count number of users who get rated, so these two together, and then number of people who will get slightly higher rating. So this is just simple math. My submission for this problem is just I don't know. A people didn't make any submissions, they are unrated. So if A people are unrated, then n minus A are rated. And similarly, you just subtract non-rated people, subtract low-rated people, and then you get slightly higher rated people. So yeah, simple math. In second problem, chess rating. Alice playing chess, she has some current rating, she has some target rating. Every time she wins, her rating increases by roughly 8 points, and she wants to find the minimum number of games she needs to win in order to get a higher rating. So in this problem, my solution is well, you need some difference that you want to cover. You need your rating to increase by at least this difference. Every time you win, you get plus 8, so you should roughly divide by 8. Then plus 7 is for rounding up. If you want to round up in C++, you divide by k and you add k minus 1. You can work from examples to see why this works. But also, if our current rating is already y or greater, then we don't need any wins, but this formula may tell us negative values, so we will take maximum with 0. In third problem, recent contest problems. So Chef missed 2 contests, lunchtime and starters. I took part in starters, but I also missed lunchtime, so it's kind of relatable. So here he sees there are some problems. For each problem that he missed, he knows whether it comes from lunchtime or from starters. And we are given those strings, and we need to count basically number of occurrences of starters and lunchtime. So there is nothing interesting. You just, I don't know, you count how many times start occurs, how many times lunchtime occurs, and then you print it. A nice way in C++ to loop over something. I didn't want to copy paste code that counts twice, with just different codes, so I created additional for loop that loops over problem codes. This way, if we had more problem codes, I don't have to copy paste this line again. I just add more elements into this vector, and vector can be created in place when it's needed. In the next problem, we need to find optimal strategy in which order you should solve code forces problems. So if problem A is worth 500 points, problem B is worth 1000 points. Each minute, problem A reduces by 2 points, problem B reduces by 4 points. We know that we need x minutes to solve A and y minutes to solve B. We need to find what is the optimal strategy, whether we go for B first because it decreases faster, but we may spend more time, or we go for A first. So because there are only two possible strategies, my solution computes the value of both and then puts whatever is maximum. So I just computed by hand two values here and here. I could have like looped over all permutations explicitly, but because there were only two, I decided let's do it this way. Why not? Like writing loop over permutation probably would have taken longer. In the next problem, Chef needs to compress a video. So a video is some frames, and if we have adjacent equal frames, we can drop them, because it kind of doesn't make sense. Like nothing's happening if the frames are the same. Consecutive frames are the same, so we can drop them. So here we can drop one, here we can drop two. So conveniently enough, in C++ there is in STL there is function unique, which does just that. It almost removes element from vector, adjacent duplicates, it deduplicates. So like it moves duplicates to the end of the array, and then we erase unnecessary elements. So this is very common C++ idiom. It's usually used together with sort. So you first sort array and then you deduplicate. But in this problem we cannot sort because it's like sequential thing, so we just deduplicate. This is a nice C++ trick to know. Or not a trick, it's just STL. In next problem, closest vowels, Chef had a string and he wanted to change every letter into vowel, or if the character is vowel, don't change it. But he also needed to change to closest vowel, and he wanted to know how many ways to do this. So obviously, like there are at most two closest vowels for each letter. For example, like for letter C, there are two closest vowels, A and E. Right, so that leaves us with two ways. But for some letters like B or D, there is only one closest vowel. So in this problem, what I did is I computed for each letter how many closest vowels it has. There is some loop that for each character loops over all vowels and then just checks, like if new vowel is closest, then all previously considered, then we need to overwrite record, overwrite closest. Otherwise, if distance is the same, then there are two closest vowels. And then answer is obviously product by product rule, because changes of different characters are independent. So yeah, you just multiply by however many closest vowels current character has, and you need to mod, because obviously it's like it can be answer is a power of 2, because all values are either 2 or 1. But it can be a large power of 2, so you need to mod. Finally, we get into division 1 problems, minimize block throws. In this problem, there is a pandemic in a country. Country is a tree. Some edges we cannot block, some edges we can block. If we don't block an edge, then infection spreads over it. We cannot afford more than k cities to get infected. You need to close minimum number of roads, or find that it's impossible. So what I do here, I say that it's only optimal to cut the highmost vertices that can be cut. Because if you consider a subtree that you can cut off, right? It has like a lot of vertices. If you can cut it off, it doesn't make sense to cut off smaller parts using more cuts. Let me demonstrate what I mean. So let's say I have some subtree, right? Because why not? So I am allowed to cut this part off entirely, right? Then I say, well, it's the best we can do in this subtree, because let's say what else can we do? let's say we can also cut like this part, or like one of them, this part and this part, and no. So you can see that red cut, it's like it's only one cut, but it takes a lot of vertices out of the tree. So it's clearly optimal to only use cuts that are as high as possible, because here you are using more cuts and you are getting less less cities safe. So you need to cut like the edges closest to root. So I do this. I do DFS. My DFS checks if it was possible. There are two parameters, current vertex, and if it was possible to cut some edge on path from root to us. Because if it was possible, then it doesn't make sense to do any operations. So I will record optimal cut sizes. Cut size is a candidate to be optimal if there were no possible cuts above us, but like directly this time, but V can be cut off. And we are the closest city that can be saved. This is a good way to think about it. We are the closest city that can be saved. No city before us can be saved, but we can be saved. So yeah, I just record subtree sizes, and for such special cases, I record them in a separate vector. Then I say like it's optimal to cut off the largest part first. So I sort. Then I take largest, and like I perform one cut and I remove largest from the sum. Sum is how many cities get infected if I don't do anything, right? Then I cut one part off, so number of infected cities decrease. And yeah, I do just this as long as I need to, and I can. If I succeeded, then I print the number of cuts, otherwise I print -1 because it's not possible. So yeah, just a greedy plus DFS. In next problem, even Subarray XOR, we need to construct two arrays with completely different elements, and such that XOR of all even-sized prefixes was the same. And notice that it only needs to happen for even-sized prefixes. So I thought like, okay, this basically tells you that XOR of every consecutive pair in A and every consecutive pair in B should be equal. How to do this? Well, let's say that in A we constructed A some way, then in corresponding pair in B, let's just flip one bit, one new bit that was not used in A. By doing this, I will like clearly get the same XOR. And also, if this bit was not used previously, then all elements will be distinct. So the only tricky thing here is that which bit do you make new, which bit do you make specific to flipping? I made the lowest bit. I think you cannot make highest bit because of the constraints of the problem. So what happens, like array A is just all odd numbers, array B is all even numbers. You can clearly see that this +1 and +1 on the next iteration, they cancel out when you take XOR. So yeah, this was the solution. Very nice constructive problem. I mean, kind of obvious, but okay. In next problem, crazy substrings, in the Gotham City, there are some types of people. People of the same type are friends, people of different types are not friends. Batman wants to get as many friends together consecutively as possible. For this, he can perform the following operation: reverse some substring. We need for each number of operations from 0 to n, find the longest range of friends. So there are two things. First, you need to observe that anytime you reverse a substring, you essentially merge two groups of friends together. For example, if you reverse ABC, then you merge this A at the beginning and this A at the end. And for any two groups of friends, of already consecutive friends, you can merge them. It's not hard to find the corresponding substring. Like, just draw a string. Yeah, let me actually draw. So this is your string, here goes your first group, somewhere here goes your second group. So how do you get them together? Well, you reverse this entire thing, right? Because then this gets here, this gets here. So this part gets adjacent to this part. Very poor drawing on my side, but whatever. So yeah, you merge two groups of friends together. Clearly, it's optimal to merge longest groups. So let's take a look at my solution. I actually got 2 wrong submissions due to very silly mistake. Yeah, I will not show it to you. You can try guessing in the comments. Actually, if you watched this far, try guessing what mistake I had. And then you can obviously check by going to the corresponding submission. Yeah, the winner will get something from me if they don't look it up first. So I use this trick, append sentinel, to automatically terminate last group. Then I find groups of consecutive characters, very easy thing to do. By the way, this is the part where I had some bug. Try guessing. So then for each character, I record a length of the groups of this character. Then I sort them. I take longest first. I merge them with my current group and I increment the number of operations. And then I update, like I said. Okay, for this number of operations, I get this, I can't get that many in a row. Then because we needed to kind of propagate these updates further, if you can get some answer in I operations and in at most I+1 operations, you can also get. Excuse me. I didn't drink in a while. And I need to keep my throat hydrated. Because yeah, it's hard to speak non-stop to the camera. Sorry about that, guys. So yeah, we propagate these updates further in this way. Because we only updated for given number of operations, and in the problem we needed to answer at most key operations. In the last problem, yet another palindromic problem, we were given a tree. We're concerned with LCA, and each vertex in a tree, they had character labels. In this problem, you were given queries of the form 2 vertices. Then you need to take some subsequence of paths from first vertex to LCA, some subsequence of paths from second vertex to LCA, concatenate them, and get a palindrome. So you need to notice several things. First of all, you need some way of calculating LCA. Second, simplest palindromes that you can make are short. It's easy to make short palindromes, it's hard to make long palindromes. So the simplest and the shortest is 2 characters that are equal, and not 1 because they need to be non-empty, in case you're wondering. So yeah, essentially the problem reduces to check if there is the same character on path from U to LCA and from V to LCA. Oh, and I just realized a much nicer way of solving this. Or have I? No, I didn't realize much nicer way, but there is another way of solving this problem than what I did. So my solution for this problem is I had some LCA pre-written class on my GitHub. In my code forces repository, there is LCA and there are some problems, and there is the class. It has some very stupid interface, but this is the first idea that came to my mind. But also I count how many times each character occurs on the path from root to current location. For this I need DFS. And also DFS helps me orient the edges so I can add them straight away. So counting characters on path from root to current vertex is not hard. You can probably do it yourself. Then I compute LCA, check if any of them is equal to LCA, then it's kind of impossible to select non-empty subsequence of empty subsequence, so answer is no. Otherwise, for every character, I check if it occurs on the pass here and on the pass here. If it does, great. If it doesn't, also great. We solved the problem. So yeah, thanks everyone for watching, and let me know, try guessing in the comments what was my bug for the previous problem, crazy substrings. Once again, thanks everyone for watching, and I'll see you someday with another contest. Bye bye.